Okay, so this gets us to the EWR Chapter 2. A lot of stuff in this chapter as well, so I'm just going to briefly hit on some things I think need a little further explanation here. First is the term yoke over here. So I'm going to jump ahead to page 56. So the term yoke, they go ahead and say the NEC doesn't actually define it, but they're going to go ahead and define it as the metal or polycarbonate mounting strap on which a wiring device or devices are attached. So if we want to see a picture of one here, I would say these sort of metal straps here, that's what they mean by yoke. So when you see yoke, you can almost think of one device that fits in a single gang spot would be one yoke. So most of your devices are one yoke. You get the larger devices, think of a dryer receptacle, maybe that's going to be a two yoke situation at that point. Then the other item in here that I think is it's kind of a tough section. There's a lot to it. Again, very important stuff, but is number of conductors in a box, jumping over to page 57. So how do we know how many conductors we can fit in a box? Well, the first step is how much volume is in any given box, and here on table 314.16a of the NEC, they're going to actually show us that. So they have a variety of different boxes here. You're going to have your octagons, your 4x4 square boxes, your 4x11/16 boxes, and then your last number here in every one of these columns here is actually the depth of the box. That's the only thing that changes within the categories. But then they're going to show you the cubic inches of any of these boxes. How many cubic inches of volume do they contain? So then jumping over to your next page here, we then have table 314.16b from the NEC, which tells us, well, how many cubic inches does any given wire take up? What is the volume allowance per conductor? Okay, so you see you have your different wire sizes here. Each one of those requires a different amount of cubic inches. Okay, the ones to note for sure are your number 14 is 2 cubic inches, your 12 is 2 1/4, and your 10 is 2 1/2. You're going to see a lot of those, of course. And then I want to run down through here. They tell you, well, okay, what about the other stuff in a box? Your receptacles, maybe even your wire nuts, your straps, things like that. How do we account for them? And some, you'll be surprised to learn, you actually don't have to account for. So of course, first thing, any current carrying conductor in a box, any hot, any neutral, you're going to count that for what it is. If it's a number 12, you're going to add a volume allowance of 2.25. Simple as that. But where it starts to get a little tricky is, let's go through some of these here that are common. A clamp, an internal cable clamp, okay? Not a clamp on the outside of the box, but an internal cable clamp. You're going to add one single volume based on the largest conductor in the box. So if a 12 is the biggest wire in that box, you have an internal cable clamp, add one volume allowance at number 12. If there's 2, 3, 4 cable clamps, you're still only going to add one. Okay. Next one here is device or equipment. So a receptacle, a switch, something like that. How do we account for that? That's going to be a double volume for each yoke. There's that term yoke, based on the largest conductor connected to that device. So if you have a receptacle that's got a 12 and a 14 connected to it for some reason, you're actually going to count it as a double volume for number 12. Okay. And then moving on to equipment grounding conductor. Surprisingly, we only have to add a single volume based on the largest equipment grounding conductor in the box. So if there's 4 equipment grounding conductors, which one's the largest? Add one volume allowance based on it. Okay. Basically all this stuff down here, I'm not going to read you through it, but please read through it yourselves. What it basically says is we don't have to count a short pigtail. We don't have to count wire nuts. We don't have to count small fittings, lock nuts, things like that, surprisingly. Okay, so the big things: current carrying conductors, grounding conductors, internal cable clamps, devices. Those are the ones you're going to see the most, especially in your book work. So I want to jump in. I got a little slideshow here just to kind of show you my method for figuring this out. So this first problem actually comes right out of your textbook. It's one of your worksheet problems, so I'll let you guys figure out which one that is exactly. But so they're going to tell us here basically things to note. Every one of these cables coming in does contain a ground, as represented by this bare copper wire. They're all 12 gauge conductors, 12-3 and 12-2 up here we see. Looks like we have one receptacle. Looks like we have some external cable clamps, not internal. Okay, so the first thing I like to do, kind of what I just did, let's just do a rundown and say, what do we have to count here? Okay, we've got to count our current carrying conductors, of course, the hots and the neutrals. We got to count our grounding conductors. Again, one volume allowance for largest ground. We have to count our device, 2 volume allowances for the largest conductor connected to the device, 1 volume allowance for internal cable clamps. Okay, we have external, so we should be in good shape there. Okay, so what I like to do is first I'll just kind of do like a tally mark for every count in each category. And in this case we only have number 12s. If we had different wire sizes, I would do this for each individual wire size and come up with a tally, a grand total. How many number 12 volume allowances? How many number 14 volume allowances? Again, in this case we only have number 12, so we're only going to have to do this process once here. But let's go ahead and count our current carrying conductors, and you'll see I'll just kind of add a little slash mark over here and keep a tally, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. So I think we got them all there for a grand total of 8. Remember, we're not worried about these little pigtails. They don't have to count in our grand total count. So 1 volume allowance for the largest ground. I know that these grounds are all number 12s. I only have to count 1 volume allowance period, so I have a 1 for a total there. 2 volume allowances for the largest conductor connected to a device. Largest conductor in this box is 12, so I'm going to have 2 volume allowances for number 12 for your connected to your device. And then internal cable clamp, we don't have any, so quite simply that's a 0. Okay, so at this point I would then add this whole tally up and see what's my grand total. How many number 12 volume allowances do I need? Of course I get 11. So now what I'm going to do, okay, I have 11 volume allowances. Well, how many cubic inches do I need for these number 12? And that's where you're going to refer to your table 314.16, which is again in the code book. It is in your EWR book, but please go to that in your code book so you know where that's at as well. So again, we're using number 12s here. As we mentioned previously, I need 2.25 cubic inches per number 12 volume allowance. So I'll come over here and multiply my total of 11 by 2.25. Of course, that's going to give me 24.75. So that's the total cubic inches of volume I need to contain within my box. So the next step of this, to take it full circle, is what size box could I actually select? Well, for that you need to know what kind of box are we dealing with. And for this example, I'm just going to stick with a 4 square box, so a 4x4. And then we need to select what is the depth of that box, 1.25 inches, 1.5, or 2 1/8. Okay. Again, we need it to contain 24.75 cubic inches. So I'm going to look in this section here. That's where my 4 square boxes are, right? So my first inclination, let's check out these 2 smaller ones. I can see 4 by 1.25 inches only contains 18 cubic inches. 4 by 1.5 inches only contains 21. Neither one of those is going to quite cut it for me, so I'm going to have to go down to the big guy there, the 2 1/8 deep. Of course, that takes 30.3 cubic inches, which is less than my 24.75 inches that I calculated. So that this volume can fit within this box. Okay, so that's your box selection. Again, the only real different part is if you add maybe more than one size current carrying conductor, you're going to have to do that process once again. But again, that's your box fill, kind of the complicated task of the section. So good luck, and again, please reach out if this trips anybody up. There's a lot more under the surface here that could be going over.